Hello friends, welcome back. In the previous tutorial, we have got some information about structures and classes. In this tutorial, we are going to get some more information about structures and classes. Here we are, structures versus classes. In this tutorial, what we are going to do means we are going to understand the structures code execution and the class code execution. First, we understand the difference between structure and class. Let us understand. Now, if I need to create a structure, we are going to use struct keyword. If I need to create a class, we are going to use a class keyword. The meaning of structures and class is different. Even though syntactically they look little bit same, only difference you can find here is the keyword that we are using, but semantically they are different. Their meaning is different. Structures are value types, whereas class are reference types. Now, value types means the values are going to be stored, whereas in reference types, the address of the memory locations are going to be stored. That you should remember. As structures are value types, whenever you create a new structure, it will get created on the stack and removed when its scope will end. Whereas whenever you create a new instance of a class, then it will get created on the heap and it will be available for a longer time until the garbage collector collects it. That means you have to use structures for lightweight objects. If you want to create lightweight instances, small structures, then you can use structures. If you want to create a heavyweight objects, then you can use classes. Now, as structures are going to be created on the stack and removed from the stack, they execute more faster, whereas class execution is little bit slower. Structures are used for short-term purpose calculations. Like you can use structures to create point, rectangles, mathematical structures. You can create mathematical objects. Until and unless you do not need a reference type, then you need not to create the class or class type of objects or reference type of objects. I hope you guys are understanding the difference between structure and class. Now what we do now, we understand the execution of the code, then one by one we list out the difference between structure and class, when we have to use a structure, when we have to use a class, and we get some more information. Let's get started. We compare both of them. Here we are. When we run the code, we know that first start method is going to be allocated on the stack. Here we are. We have a start method on the stack. Same thing happens here also. When we run the code, the start method will be allocated on the stack. Then we know that when the control moves inside, it just executes this line. Here also same thing, the control moves inside. It finds there is a line to be executed. First thing, on the left hand side you can see, we are saying point P1. What the control is going to do? It is going to think that I need to create a memory location with the name P1 of type point. As point is a value type or a structure type, what the control does? The control is going to create a memory block, friends, with the name P1. That block is going to be equal to the sum of sizes of the fields that are present. At present there are two fields, both are of float types and both are of 4 bytes. So 4 plus 4, 8 bytes. And what it does in that memory block, it creates two memory locations, one for X, one for Y. One for X, one for Y. And let's take its address is #1. That's what it does. And it will, even though it initializes these two memories to zeros, as it is a value type, the system understands that these memory locations are not assigned. They are not yet assigned. If you do not assign, then the system considers that you cannot use them. You cannot use the P1 if you do not initialize both the members. What I do now, I just copy this from here. I paste it. Here we have point P1, friends. The members of P1 are not initialized. Then we have equal to sign. As we have equal to sign, the right hand side part is going to get executed. Before we proceed, let's come to the right hand side. Here also same thing. First point P1 is going to get executed. Now what control understands that I need to create a memory location with the name P1, and the P1 is of type point, and the point is of type class, and the class is of type reference type. So on the stack, what system does, it creates one memory location with the name P1, and let's take its address #1. As it is a reference type, it puts the value null inside it. So you can understand the difference, what is happening. I copy this from here. I put in this place. We have point P1, the left hand side. This is what happens when the left hand side get executes in the structure. This is what happens when the left hand side of the statement get executes with respect to class. Then let's come to left hand side. As we have equal to sign, we know that the right hand side part should get executed. First it executes the new keyword, and we know that what new keyword does, it allocates a new memory block on the stack, and it checks which type you want to create. You want to create a memory of type point, which is a structure type, which is a value type. So it allocates the memory. It allocates a memory on the stack. So it creates another memory block, and both memory blocks are at present uninitialized. They are not initialized, you can see. And we know that the memory block is going to have some address. Let's take this one is a #2. And the members of this memory block are not yet initialized. Even though the new initializes these members to 00, they are considered as not initialized. They are not initialized. So to initialize that, what happens means the new invokes the point constructor. Understanding? Let's come to the right hand side. Here also same thing. As we have equal to sign, the right hand side part should get executed. Here what happens, the new keyword is going to get executed first. What new keyword does with respect to class, it creates a new memory block of type point on the heap, friends. What it does, it creates a new memory block on the heap. Let's take its address is #2. And this complete memory block is of size 8 bytes because two members are there, both are of 4 bytes. It creates two memory locations in that block, one for X, one for Y, and both of the memory locations are going to be initialized to 0, and system considers that these memory locations are initialized, whereas with respect to structures, they are not initialized because they are value types. Here in reference type, the system understands that they are initialized. Even though they are initialized, to re-initialize, the new is going to call or invoke the point constructor. Understanding? Let's come to the left hand side. The point constructor is going to be called. It is not going to be simply called like this. The new is going to send or pass the address of newly created memory location. On the stack, the new keyword has created a memory block which has the address #2. That #2 will be sent to the point constructor. Now same thing happens on the right hand side. Let's come to the right hand side. The new is going to invoke the point constructor. It is not going to just invoke the point constructor. To the point constructor, when it calls the point constructor, it sends the address of the newly created memory location which is on the heap which is created by the new keyword. Understanding? Now here we are. When the point constructor gets called, we know that structures, every structure in the class is going to have an implicit default constructor always available in every structure and class. And we know that behind the scene, we assume, as I told that we know already how actually behind the scene the constructors look. But from here onwards, we assume that the constructors are going to have the return type as the structure name itself. In this place point it returns, and the name of the constructor is going to be same as the name of the structure. Here the point constructor is going to have one extra parameter, that is going to be this. The name of that parameter is this, which is of type point or which is of type structure, and it behaves like an out parameter. Here it is going to have two statements, this dot x equal to 0, this dot y equal to 0. Now we know that constructors are going to have the same name as the structure name, and behind the scene we assume that they return the same type as the structure type, as the point. Here in our case it returns a point, and we will be having at the end the last statement will be return this. Understand this, one extra line. These two things we are assuming. Now similarly in the class also you will be having a constructor which is going to be something like this: public point 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 this, opening brace, closing brace. Actually here we will not be having this dot x equal to 0, this dot y equal to 0 in the class, but yet we consider this dot x equal to 0, this dot y equal to 0, and we will be having a last statement in the constructor, return this. Here we are assuming the return type is of type point and returns this. These two are assumptions. We know that the constructors are going to explicitly, they are not going to have any return type, but implicitly they have the return type void. We proved that in the previous tutorial. When the new invokes the point constructor in the structure, we know that the control is going to jump to that constructor. Now what happens on the stack? You are going to have the point constructor friends. Point constructor is now allocated on the stack. Now same thing happens with respect to class. When the new invokes the point constructor, the control moves to that constructor, and what happens? The point constructor is going to be allocated on the stack. Here we are. Now we know that the point constructor is having one variable, this. So this is a memory location available in the point constructor. Here also same thing on the right hand side. Here also we have a this. This is a variable available. Now you should understand here that #2 will be sent and will be stored in the this variable. Now this variable is going to have here #2, as this is of point, and point we are here telling out type, so this is a reference type. We store #2 in that. Once the address gets stored, it starts pointing to that memory block. Here you can see that it is pointing to that memory block which is created by the new keyword. Now this is pointing to #2 memory block. Now same thing happens with respect to class. When the point constructor gets called, #2 will be sent to the point constructor, and there is a this variable. This is of type class, and class is of course reference type. #2 will get stored in this variable. #2 will get stored, and we should remember that once you store the address in any reference type, it starts pointing to that memory block. On the heap we have #2, so it starts pointing there. After that what happens? Let's come to the left hand side. Left hand side, this dot x equal to 0, this dot y equal to 0. So here the control initializes the members, this dot x equal to 0, this dot y equal to 0. Let's come to the right hand side. Here also the control moves inside, this dot x equal to 0, this dot y equal to 0. This dot x equal to 0, it reinitializes them. This dot y equal to 0, it reinitializes them. But actually this initialization is already done by the new, because new is responsible for initializing the members of newly created instance. Understanding? But here we assume that it is also done by this constructor. After initializing the members in the structure, we are assuming that it returns this back to us, as this is of type structure, and you can see the return type is point. In this place, point is a structure and the structure is a value type. As it is a value type, we know that this keyword is going to return the value at this is pointing. Whereas when you come to this side, right hand side, we have assumed that we have a return this as a last statement. You can see we assume that the return type is point. As point is of class, class is a reference type. Here return this will return the address which is present in the this. It is not going to return the value at this is pointing. That means what happens here, return this is going to return the value at this is pointing. It returns back in this place. Understanding? So we get that here, I just put it over here. And we have a semicolon. This is going to return back to us the value at this is pointing. As the control has come back, we should remember that we will not be having the point constructor now on the stack. So we don't have this variable. Then let's come to the right hand side. Return this. This is going to return back the address that is stored in the this variable in this place, that is #2. So I copy that #2 and that will be returned back. I place one over here and also I paste and send that back, and we will be having the semicolon. That is what happens, my friends. And when the control comes back, we know that the point constructor will not be available here. We have here point p1 equal to new point. That is, the situation is now left hand side we have a point, right hand side we have another point which is returned by this. Now what happens here means the system will initialize the memories respectively. p1.x is going to become this memory location's x value, so this will be initialized to 0. That means p1.x is going to be #2's memory location's x, that is going to be 0. p1.y is going to be this memory location's y, that is #2, which is returned the block address. So here it is going to become 0. Here same thing, p1.y is going to be #2's memory location y value, that is 0. Once the values are initialized, the control moves to the next line, and that's the end of this memory location's scope. Then the memory will be removed. This is how the code executes on the left hand side. Let us see the right hand side. Here what happens, #2 is returned back, and we can see that left hand side is a reference type, right hand side is a reference, that is address. So what happens here, now p1 will be initialized by #2. Now here we are going to have #2 stored. That means you should understand that in the stack you are not going to have the p1 null, it is going to have #2. And we should remember that once you assign the value to a reference type, it starts pointing to that memory block. After executing that line, the control moves to the next line. This is how the code works in the structures and class. I just showing you the difference between the structure execution, code execution, and the class code execution. At the end you can see that we have the P1 fully initialized by x0, y0. Here also same thing, P1 fully initialized by the xy, both are 0. And you can see what is the status of the memory also. This part I have explained, this part I just kept for your understanding purpose. I hope you guys have understood how the structure code executes and the class code executes. Please see this tutorial again and again and understand. Upcoming all the video tutorials we are going to understand in this way. Now we understand a little bit more about structures. Here we have created a struct point float x, float y, and we created a point p1 is equal to new point. What I do, I remove this and I put a semicolon. Here you can see that you can create a point without using equal to new point. You need not to use a new keyword. Without using that also you can create a point p1. Now what happens here, as p1 is of type point and point is of type structure and structure is of type value type, the system considers that the p1 is not fully initialized. That means its members are not initialized. Even though the members are going to have x is 0, y is 0, system considers that it is not fully initialized, or the members of the p1 are not assigned. You can understand that. Even though you create a point, point p1, the system understands that they are not initialized. Let's come back here and just show you that if I say here debug.log, I want to see the x member value. How do I see the x member value of p1? I should say the name of the object or the instance, then I should put a dot. Now dot is known as member access operator. It's a special operator. Dot is a member access operator. Now what we need, once you put the dot, automatically this IntelliSense shows the different members that you can access by using this p1 instance. There are some methods which we can access, but we understand them what are they little later. Because these are the methods which are automatically inherited by the object class. Now structures are actually inherited from the object class. We don't want to know at present all those things. So here you can see that it is not showing the x field and the y field. The reason is, by default structure members and the class members are private members, friends. Here if I put x, then I say here debug.log, I say p1.y bracket close semicolon. I save this code. If I come back to Unity, you get an error message. Here you can see that I want to use the p1. Use means I want to display the members of the p1. I want to see what are the values in x and y which are members of p1. I want to use, but system has some problems here. First problem is the access problem. Here the x and y are private, so we get the error message. You can see that we got two error messages. First one is point.x is inaccessible. You cannot access it due to its protection level. Point.y is inaccessible due to its protection level. What is the meaning of that? The meaning of that is the members that you have in the structure and the class, they are by default private members. Private members can be accessible only within the block of the structure or a class. Private members can be accessible only within this block. These private members can be accessible only within this block. These members you cannot access in some other block, I can say. These members you cannot access. These members you cannot access in some other blocks. That is the reason when we have returned p1.x, it is telling that they are inaccessible because by default these fields are private to the structure. If you want to access these, you can access only within this block. You cannot access in some other block. Understanding? So, first of all, I need to convert them to publicly available. Instead of private, I need to make them public members or public fields. How do we do that? Just before the data type, you need to use a keyword called as public. Understanding? So here also I write public. Now once you have written public keywords, they become public fields and you can access them anywhere. In any other blocks you can access them like this. Now this time if I say P1 dot, you can see that IntelliSense is showing X and Y. You can access them. It is telling you can access them, and it also shows that this is a public member and it's a float type. Now we are going to get another error. After solving this, if I save and come back, we get another error, that is unassigned. As we know that the point P1 we have created, as it is a value type, system considers that the members of this P1 are unassigned. If the members are not assigned fully, then we cannot use them. That means I cannot show the value inside X and Y. I cannot use it. Let us see those errors. These errors will go away. Some other errors have come. And what are they? First one says use of possibly unassigned field X, use of possibly unassigned field Y, and you can see that you are using the field Y that is possibly not assigned. That is what system is telling. So I have to assign the X and Y members of the P1. How do we assign them? How do we initialize the values? How do we initialize means, with respect to structures, there are two ways. This is a standard way. We have to call new point. We have to call the constructor, because constructor is responsible for initializing the members of the point P1 in this situation with respect to the structure. So when we call the point constructor, it goes to the point constructor, the members are going to be initialized, and that new memory block, fully initialized memory block, will be returned back to us. Right friends? So what I need to do, I need to say here equal to new point bracket, and we know that new is going to create a new memory block on the stack, and the point constructor, a default constructor is going to be called, and that will initialize the members and return back us a block having the X and Y fully initialized to 0, 0. Then what happens? Corresponding memory locations of P1 or members of P1 are going to be initialized by the respective memory locations on the right hand side, that is the returned memory block, that is X and Y values of the memory block. One by one the values will be copied to the P1. Now the system considers that the P1 is initialized. Once the P1 is initialized, you can use them. If I save this code and come back to Unity, we should not have the error message. You can see that we don't have any error message. Errors have gone. That means we are initialized. If I run the code, we are going to see the X value 0, Y value 0. If I run the code, you can see that 0, 0. We got the output 0, 0 friends. That is what we have on the left hand side. That's what happens. That is how the code works. Now let us come to the right hand side. What we do, we convert this structure to the class CLASS class, and I remove all these codes. First of all, I say point P1. Now we are comparing. I am writing point P1. Now what is point P1? P1 is of type point, and point is of type class, and class is a reference type. So P1 is going to have by default null value inside it. Here what I say again, debug.log. Let me remove this public because I just want to show you first. Here I say P1, I put a dot. You can see that I cannot see X and Y members because they are private. I just put X semicolon, debug.log P1.y I save this. If I save this and come back, we are going to get the protection level error. If I come back, you should see those two errors. Point.x is inaccessible due to its protection level. Point.y is inaccessible due to its protection level. Come back. Let us come and change them back to public. If I make them public, I can access the x and y in some other blocks now. If I save and come back, this time we don't get the protection level error, but we get unassigned error. Possibly we are using the memories which are unassigned. Let us save and come back and check out. You can see that we got an error, use of unassigned local variable p1. First of all, it is showing that this p1 only not initialized till now. You have not initialized the p1 itself, because p1 has the value null. Even though it has a null, system considers that it is not initialized. So what I do, I say equal to null. Now let us understand what is null keyword. The null keyword is a literal. That means it's a constant that represents a null reference. One that does not refer to any object. If you have the null in some reference variable, it will not refer to any object. That means it is not referring to any object. Null is a default value of reference type variables. That is what we have to understand. P1's default value is null even though you do not initialize. Let us put it. If I save and come back, this error is going to go away. The error that we have at present, that P1 is not initialized, go away. We get some other messages. Unassigned, this will go away. You should see that. But we get these two messages. Point.x is never assigned to and will always have its default value 0. And you can see that here we are not getting the p1.x and p1.y are unassigned. Errors we are not getting, but we are getting warning messages that p1.x and p1.y are not assigned. By default, they are going to have x and y values set to 0, 0. That system considers that x and y are already initialized. Understanding? If I save this and come back and clear this error warnings and run the code, what we have got? We got an error message. What is that? Object reference not set to an instance of an object. This is an important error message. Actually, this is a null reference exception, guys. You can see that. Let me clear this. Let me modify this again and save the code. When I come back, system compiles this file. At the compile time, we didn't get any error message. But when we ran the code, we got that error message. Any error that you get at the runtime is known as exception. In our case at present, we have got null reference exception. What is the meaning of that? Object reference not set to an instance of an object. It is telling that you are trying to access the x and y memory locations of the P1 and the P1 is not pointing anywhere. It has the value null. Then how can you access the x and y members? Syntax is correct. There are no compile time errors. But at runtime, P1 is not pointing. You cannot access x and y members, my friend. Understanding? That is null reference exception. So you get this exception many times if you are making game. So remember this exception and what problem we get because of this. How do we solve it? What I need to do? I need to make this P1 to point to some point. What I do? I say here new point. Now this time what happens? The new keyword is going to create a new memory block on the heap, and the point constructor is going to initialize the members and returns back the address of that newly created memory location. Then #2, that is the address, will get stored in the P1 and the P1 starts pointing to that memory location. Now I can access the P1.x. I can access P1.y. Let us come back and save the code and come back to this. We should not have any error message. If I run the code, we are going to get the result as x equal to 0, y equal to 0. Understanding, friends? This is how the code works. I'm just showing you the different errors. What is the meaning of the null keyword? What is an exception? How do you solve that exception? Understanding? And how the code works with respect to the structure, how the code works with respect to the class. Now let's understand the execution of the code through the debugger, Unity's debugger. To make you understand the code, what I need to do means I am going to create an explicit default constructor. We know that already every class and the structures are going to have by default a default constructor available. Here explicitly I am going to create myself a constructor. Now we should remember that I need to have the constructor as a public. You can read the public. The public keyword is an access modifier for types and type members. Type here is the class, type members are X and Y. Public access is the most permissive access level. There are no restrictions on accessing public members. There are no restrictions. You can access public members anywhere you want. I need to write public so that I can access the constructor in some other blocks. Like here I am accessing the point constructor. Now we know that explicitly constructors are not going to have any return type. Explicitly you cannot write even void also. Understanding? But implicitly we know that the constructors are going to have void as the return type. Then I need to give the name of the constructor. We know that every constructor is going to have the same name as the data structure its name. That is in our case the class name point. So constructor name is same as the class name. And the default constructors are parameterless constructors. That means they don't have any parameters explicitly. Opening bracket and closing brace. Then here I say this dot x equal to 0. This dot y equal to 0. Now you are telling what is this? This dot x, this dot y? Yes. Here as I told that the constructors are going to have this member. And inside the blocks we have this dot x equal to 0, this dot y equal to 0 to initialize the members. This is how the code is written. And as I told, every non-static constructor and non-static methods are going to have one extra parameter, and that parameter name is this, and this always points to the current object. Now let us understand. I put a breakpoint over here. I attach the debugger and come back to Unity. If I run the code, you can see that we got a break over here. Here you can see in the locals you can see that at present start method is on the call stack, and in the locals we have two variables. One is this keyword, another one is p1. You can see that the start method is a non-static method. Even though it has no parameters, as we know that always one extra parameter is there, and that name is this, and this is in this start method of type struct class demo. And we can see that we have p1 as it is the reference type. By default the p1 has the value null, as this line has not got executed at present. Now if I say step into, we know that the new memory block is going to get created on the stack. That is in the locals we see a new memory block. To that new memory block, so this is going to point. We can see that the point constructor is going to get called now. We can see that the point constructor has been invoked by the new keyword, and here even though we don't have any parameter, we have one extra parameter, that is this, and this is at present pointing to this newly created memory block. To the newly created memory block as it is pointing, it has the members x and y both already initialized to 0, and you can see this is of type point. That's what we have written here. This is of type point in the class. Once again we initialize one by one. So this dot x equal to 0, this dot y equal to 0. After executing this, the control will come back. The p1 should not be null now. P1 should be already initialized by #2 in our case, and the p1 should have x and y both initialized to 0, 0. Let us come back. You can see that now the p1 is not null. It is of type point. You can see that. And if I open this, p1.x is 0, p1.y is 0, friends. Here you can see that p1.x is 0, p1.y is 0. That is how the code works. Now if I execute these two lines, we are going to get the output 0, 0. Run the code. And if you see here in the Unity, you can see that both are 0, 0 friends. We got the output. That is how the code works. I hope you guys have understood. Now what I do, I convert this class to structure so that we can understand how the code works with respect to the structure. I just need to change only one line. If I do like this, we are going to get one error message. And what is that error message? Let us understand and then we solve. I just save this file and come back to Unity. We are going to get an error message that structs cannot contain explicit parameterless constructors. You cannot have explicitly parameterless constructor. That means you cannot have explicitly a default constructor. You cannot write yourself a default constructor. That means you need to remove this. Understanding? Even though you don't write, implicitly it is there. Understanding? I just save this. If I save and come back, we should not have that error message. You can see that the error has gone away. And it makes sense also, because we know that the new keyword is not going to initialize the members. The point constructor, the implicit point constructor is going to initialize the members of a value type. So we need not to have to write ourselves the default point constructor in the structures. We have seen that here. Implicitly we have this point and it initializes the members to x and y to 0, 0. Understanding? And it is of type out. It will initialize all the members. Now we come back and run the code to understand how it works. Here we are. You can see that point P1 is going to get executed first. We know that. And we are also having this keyword which is of type struct class demo, which is present in the start methods as a parameter. Even though we don't have here, we cannot see explicitly, but behind the scene there is a this parameter in the start method, because start is a non-static method. Then we have P1. As it is a value type, already the memory block has got created. X and Y are initialized to 0, 0. Even though they are initialized to 0, 0, we know that they are considered as not initialized. So we need to call the point constructor which is going to initialize. Once I execute this line, the P1 is considered as P1's members X and Y are fully initialized. The system considers that they are fully initialized. You can use them. You can see now P1 and P1.x is 0, P1.y is 0. Both are same, no problem. If I execute these two lines, we are going to get the output as x equal to 0, y equal to 0 friends. This is how the code works behind the scene. I hope you guys have understood. Now whenever I create a new point, you can see that by default the members are going to have their default values 0, 0. In our case here, as they are float, they are having 0, 0. If I want to initialize myself some other values, I want to put some values myself. That means I want to initialize whenever I create a new point, the memory location should be x and y should have the values. Let us take 10, 10. Now here I just copy this code one more time. I paste it down. Here 2 points we are creating, P1 and P2. Point P2 equal to new point, and P2.x we can see, and P2.y we can see. We are creating 2 points. If I save and run, if I deattach, I save it, come back and run the code, you should see here, if I run the code, you should see 0, 0, 0, 0. You can see that 0, 0, 0, 0. That means both the points xy components are having 0, 0, 0, 0. I do not want them to be initialized by 0 by default. I want the values 10, 10. So I can set here directly equal to 10.0f. Here I can say equal to 10.0f. This is known as field initializing. As we know that x and y are fields, we can directly initialize them. But we are going to get an error message, friends. We are going to get an error message at present with respect to the structures. If I save and come back, you should see an error message. We got an error message. What it says, point.x structs cannot have instance field initializers. That means structures cannot have instance field initializers. We understand there are different types of fields, instance field and the class fields. we understand what is instance field, what is class field later. Now at present, instance field means the objects fields cannot be initialized directly like this with respect to the structures. You cannot initialize like this. Understanding? Whereas if I change this to class and save this code, we will not be having any error message. There is instance field initializers possible with respect to the class, friends. You can see that the error has gone away. If I run the code, both points are going to have 10, 10, 10, 10. P1.x is 10, P1.y is 10, P2.x is 10, P2.y is 10. Understanding? This point you need to remember, friend. These things, whatever I have differentiated till now, from the beginning to till now, please remember that. Watch this video again and again and remember these points, so that if you get some errors later in future codes, when you will be building games or simulations, you can very easily solve them. I hope you guys have understood very clearly differences between structures and class, how they work. So for this tutorial, I think this much is enough, guys. Thank you guys. Thank you very much. See you in the next tutorial. Keep learning, keep coding, keep sharing.